Welcome back, my students, to chapter 5, lesson 4. The second type of nitrogen organic compounds are amides. Now, what is the functional group of amides? The functional group of amides is C double bond O NH2, or instead of C double bond O we can write it CO NH2, are the same. You have to notice that are C double bond O NH2 or CO NH2 are the same. Now, how many types of amides? We have 3 types of amides. The first one we call them unsubstituted amides. Unsubstituted, it means you have CONH2, and this is R. CO or C double bond O NH2. This is unsubstituted amides. But if you replace one hydrogen atom by one alkyl group, in this case we call it mono-substituted amides. Mono, it means you replace one hydrogen by one alkyl group. But if you replace these 2 hydrogen atoms by 2 alkyl groups, so in this case what you call it? Yes, it is di-substituted amide. Di, it means 2. Now if you have CONH2 or CONH or CON, all of them are amides. Here we have the definition of amides. Amides are derivatives of carboxylic acids, acid chlorides, or acid anhydrides by reacting with ammonia or amines. So they are derivatives of carboxylic acid. Here we have the carboxylic acid. R C double bond O OH. Look, R C double bond O OH. Or instead of C double bond O, you can write it CO. It is the same. And here it is the primary amine, RNHH. Now, if the reaction between OH and H, you have to remove OH from the acid and H from the amine. And in this case, they are removed as H2O. HOH, it is H2O. What remains here? RC double bond O. So this is RC double bond O. And from this side, NHR, yes, NHR. You have to join the compounds from the same place that you cut. You know, here you cut from here and you cut from here. You have to join them. This is RC double bond O NHR. So this is the amide. What is the type of this amide, by the way? Yes, it is C double bond O NH. If you have NH and this is R, you replace one hydrogen atom now. Yes, so in this case you call it, yes, mono-substituted amide. And we will discuss all types of amides. Just I explain here the definition. What does it mean, amides? Or from where they are derived. Okay, so here we have carboxylic acid R, C double bond O OH, and this is amine RNHH. Remove H from the amine and remove OH from the amides. Remove them as H2O and join the rest. We have RC double bond O and here we have NHR. RC double bond O NHR. Yes. Now, how can we prepare amides? Yes, as I said, from carboxylic acid. Here we have all methods. This is RCOOH. R, any carbon atom. CO, as I said, it is C double bond O. Yes, you know, in the previous slide, we wrote it as C double bond O, but here we can write it CO. It is the same. So you have, what is the rule? You have to remove OH with H from N. This is ammonia. So from carboxylic acid and their derivatives. I mean, what does it mean? Their derivatives. I mean, this one, acid chloride or acid anhydride. They are called the derivatives of carboxylic acid. So acid chloride or acid anhydride. And this is the carboxylic acid. So the amides are prepared from the carboxylic acid and their derivatives. With what? With ammonia producing unsubstituted amide. So if you need unsubstituted amide, I mean, you have NH2. In this case, you have to react carboxylic acid or acid chloride or acid anhydride with what? With ammonia. Look, this is NH3, NH3, NH3. Now follow me step by step how this reaction takes place. The first one, this is carboxylic acid. The rule is you have to remove this OH with H from N. Then OH is removed with H from N. Okay, they are removed as what? As H2O. Look, I wrote only this one, H. Yes, this is H from here. It is blue. This is H with OH, another H and O. Yes, from the carboxylic acid. So OH from the carboxylic acid and H from the ammonia, they are removed as H2O. What the rest here? It is CO. So this is RCO. RCO. This is RCO. And from the side, yes, we have NH2. So this is NH2. Why NH2? Because I removed one hydrogen atom. With what? With OH as H2O. Yes, the rest of the compounds, yes, RCO. RCO. And here we have NH2. So you have to join them. Don't write plus between them. No, just join them. And the second rule, with acid chloride. Okay, it is the same. But instead of OH, what we have here? Yes, we have Cl. So remove Cl. With what? With H. Yes, they are removed as HCl. Look the color. This is Cl, this is Cl. And H from here, it is blue. Yes, this is H, it is blue. Yes, I removed them as what? As HCl. They are removed. What are the rest of the compounds? Yes, we have RCO. This is RCO black. Yes, here we have NH2. So this NH2, you have to join them. Yes, now in the second rule, the third rule. With acid anhydride. Acid anhydride, we have RCO by 2O. You have to remove this one, RCO with the O. This is outside, without 2. Just RCOO without 2. Again, RCOO without 2. You have to remove all of them with what? With H. Then they are removed with H. Look, RCOO with H are removed. What remains here? You have 2. In this case, you remove 1, and what is the rest? Yes, it is 1. RCO. This is RCO. Then what we have here? Yes, NH2. Why NH2? Because I removed one hydrogen with RCOO. So these are the rules of the reaction of carboxylic acid or acid chloride or acid anhydride with ammonia. All of them, they give us the same product. Look, RCONH2 or RC double bond ONH2, it is the same. But what the difference between them? Yes, it is the side product. If you have carboxylic acid, so the side product is H2O. If you have acid chloride, so the side product, it is HCl. If you have acid anhydride, so the side product, it is carboxylic acid. Okay, is it clear? Yes, we go to the next slide. Now, with the primary amines, the first one with ammonia. Now with primary amines, you can put acid chloride or carboxylic acid or acid anhydride. The same rule. What is the rule? Yes, here we have example for the rule. Any one of them. RCOCl. Yes, you have to remove what? Cl. Yes, I know it. With H from N. Yes, I remove H from N. They removed as HCl. What the rest of the compounds? Yes, we have RCO. This is RCO. Here we have NHR. Yes, you have to write NH from the same place that you cut. Yes, I remove H from N. Then you have to join N. So this is NH. Look, NH. And go back here. Yes, it is NHR. Now, what we have here, yes, it is monosubstituted amide. Because here we have H. Sorry, we have R instead of what? Instead of H. In this case, yes, we call it monosubstituted amide. So monosubstituted amides, we can prepare them by reacting, yes, primary amines. If you have ammonia, you will get, yes, unsubstituted amide, NH2. But if you have primary amines, so in this case, yes, what we have? We have, yes, what you call it? Yes, I hear you. Yes, it is monosubstituted amide. If you need di-substituted amide, in this case you have to react what? Yes, secondary amine. This is primary amine because we have NH2. Secondary amine, we have 2R and NH. Do you remember it? Yes. Now you have to remove what? What is the rule? You have to remove H from the amine, from the N. With Cl, yes, they are removed as HCl. What the rest here? It is RCO. This is RCO. And from this side, you have to join what? N. Look. N. Then we have R, and this is R. Another R. R, and this is another R. You can put it up or down, right or left, no problem. Just you have to join from the same place that you cut. I remove H from N, then I join N. Then write R, and here we have another R. So this one, what you call it? Di-substituted amide. So from ammonia again, from ammonia we get, yes, it is unsubstituted amide. Yes, from primary amine we get what? Yes, monosubstituted amide. From secondary amine we get what? Yes, di-substituted amide. Now, what about the tertiary amine? Yes, in the tertiary amine, yes, with tertiary amine R3N, oh, there is no H attached to the nitrogen atom. In this case, yes, amides can't be prepared from the tertiary amines. Why? Because tertiary amines have no hydrogen atom attached to the nitrogen atom to be replaced. So there is no hydrogen here. So, amides can't be prepared from the tertiary amines. Examples. Yes, you can, instead of R, you can write anything. If you have CH3COOH, just what is the rule? Yes, remove OH with H, remove as H2O. So what is the rest of the compound? Yes, CH3CO, CH3CO, NH2. Okay, I know the rule. That is. What is the rule here? Yes, you have to remove H with what? With Cl. Yes, they are removed. What is the rest of the compound? CH3CO. Yes, CH3CO, and from here it is NH2. This is another example. Yes, CH3CO, Cl with C6H5NH2. I don't care about the compound. I have to follow the rule. What is the rule? The rule is remove Cl with what? With H from N. Yes, they are removed as HCl. What is the rest of the compounds? Here we have CH3CO. This is CH3CO. You have to join from N because I removed H from it. Now this is NH, 1H here because 1 is removed. The rest is 1. So NH, then what we have? C6H5. Yes, NH, C6H5. Now, do you remember the rule for this one? Yes, this is acetic anhydride. Yes, what is the rule? Okay, I hear you. Yes, yes, it is CH3CO with this O, the outside. CH3CO with this O. Yes, CH3COO. I remove it with what? With H from N. Yes, with this H. What is the rest of the compound? Because I have two. One of them is removed. So the rest is CH3CO. This is CH3CO. And you have to join from N. This is NH, C2H5. NH, C2H5. Up to here, thank you very much.